For the next part of the analysis, we come here to randomization tests, and we import the data as well. So we'll just grab the same Miley and data. And this time again we have the age as the main variable and the style as the second variable, which is the grouping variable that separates the two data sets. And in the viewing window here we see that all the red data points here are the Miley age estimates, and all the blue data points above it form the distribution or the pattern of results for the Anne estimated ages for the Anne hairstyle. Now what randomization does is it now looks at over here, we're going to use median today. It looks at the difference between the two groups, whether the actual age difference is only a year. So Miley was estimated at 28 and Anne at 27 years old, and so the actual test itself is to mix up these two groups and see if we get a chance difference of age of just 1 year. So we hit go, and it's randomizing or totally changing around which two groups those estimated ages here belong to. And in the first randomization permutation, or the first run, we see here that we have about a 2 to 3 year age difference. Now these aren't the two groups, these are just random groups, so we're just seeing that we're getting a difference of that 2 to 3 years by mixing the data up. So if we repeat this 1,000 times and hit go, each time there's a difference, it's plotting down here, in this plot here, the average distance. So these are filling up because we're getting these average distances. Now, some of the average distances or average differences between the two random ages are negative, which puts Anne as the older or younger, and some of them are positive, which puts Anne as the older compared to Miley, and down here for the negative, Anne would be younger compared to Miley. So we see here we have a distribution of differences at around 0, and if we come down here to show tail proportion, it works out that 391 out of 1,000 of our samples, or 39%, were actually greater than a +1 difference. So it's very likely that chance alone, or mixing up the groups, will give you a difference of 1 year or greater. So there's our 1 year in here, and the greater is what we call the tail, so it's also these higher ages as well. So what this is showing us is that it's even possible that you get a 5-year difference by chance. It's possible, but it's not highly probable, but you could get 4 or 3 or 2 or 1. One's very common by chance, which means that this result here isn't significantly greater to say that they're very different from each other.